Hello and welcome to Math Engine Site. I'm Zahra and here I'll be sharing what I've been learning with you. We have already talked about the importance of ferrous. The melting point of ferrous is 1538 centigrade. When the temperature of ferrous increases to reach the melting point, what happens in its structure? Ferrous, as a metal with a long-order crystal structure at a room-pressure atmosphere and equilibrium conditions up to 912 centigrade, has a BCC structure. In this range, ferrous is called alpha ferrous or ferrite. But when its temperature increases from 912 to 1400 centigrade, its structure changed from BCC to FCC. We call it austenite or gamma phase. This transmission means instead of atom being in the center, it is placed on the face with diffusion mechanism. Since the volume of FCC is larger than BCC, this transmission causes expansion while heating, and even during solidification, it will cause contraction. Now, when the temperature goes above 1400 until it reaches the melting point, the crystal structure changes from FCC to BCC again. We call this delta ferrous region. In summary, when the temperature increases, ferrous changes its structure as an allotrope and forms ferrite, austenite, and delta ferrous. We already know that ferrous is conductive. What happens when the temperature increases? There is a point called Curie temperature, about 730 centigrade. After this point, ferrous loses its conductivity properties. Ferrous used in alloy form, and carbon is one of the most important elements in its composition. However, the solubility limits of carbon in ferrous is limited and is maximum 6.67%, while 1 carbon atoms for every 3 ferrous atoms, and we call it cementite. The solubility limits of carbon in each ferrous phases and transmissions like eutectoid or eutectic that occur during heating or solidification create a diagram called Ferrous Carbon diagram. The important question is how carbon atoms are placed in the structure of ferrous. In general, atoms of alloy elements can either take the place of matrix atoms or their atomic radius is small and can be placed between matrix atoms, like carbon, either in the BCC structure such as ferrite or delta ferrous, or in FCC structures such as austenite. These new atoms with a small radius could be placed between matrix atoms with 2 different order, octahedral or tetrahedral, and octahedral is more common. Is there only iron and carbon in a steel? No, there are other alloy elements. How are these alloy elements placed in the structure? Alloy elements are placed in the microstructure in several ways. Ore like lead or copper is precipitate in pure form or combined with other metallic elements to create an intermetallic compound such as nickel-3 aluminum, or they are dissolved in ferrite. In this situation, alloy elements are placed instead of the atoms of matrix. or they are combined with, for example, oxygen and form non-metallic compounds, or they form carbide with the carbon in the structure. This phenomena decreases the percentage of carbon in the matrix structure. What kind of alloy elements form carbides? The elements that are on the left and below the iron. The atomic radius of the alloy elements is very important in order to form carbides. Usually, atoms with a small atomic radius form M3C, M23C6, M7C3, and M6C. And if the radius is large, MC and M2C will be created. What the meaning of M? M means it could be the sum of alloy elements and not just one element. For example, CrMnFe23C6. Whether these carbides are good or not good is the subject of future videos, but in order to remove carbides, we must give them temperature and time. However, solving the second group is very difficult, even at high temperature and time. Thank you so much for your attention. I hope you found this video useful. Comment your questions and subscribe for more tutorial videos. Bye.